Hey guys, and welcome to our test retake video. So I'm doing something a little different this time. You can see I've just snipped the questions that I'm going to go over, and I've copied them onto the whiteboard here. That way you can see the actual questions that seem to be the most difficult for people on the exam. So remember, after this, watch the entire video, and then at the end you'll receive the password if you'd like to retake the Unit 3 test. So let's dive right in. Number 1 here, according to the Bronsted-Lowry definition, which of the following is formed when an acid dissociates in water? So this one's asking about, I think last week we had the Class Connect session was asking about, or we learned about acids, bases, conjugate acids, and conjugate bases. And so, if we're looking here, remember this was one of the questions, I don't know if we got to this question or not, but if you have a chemical equation like this, you have an acid, base, a conjugate acid, and a conjugate base. And so we can look at this one, and we'll use this one as our example. And actually, maybe I'll just do this. I'll copy it and paste it in here. Okay. So now here we go. So in this equation, it's helpful to maybe identify what the acid is, what the base is, and what the conjugate acid and what the conjugate base are. So remember, by convention or by tradition, on the left side of the equation, these are going to be the acids and bases, and on the right side of the equation, we're going to name them the conjugate acids and conjugate bases. And so in this equation, remember the Bronsted-Lowry definition, and I'll go over this a little bit in one of the later questions. The definition of a Bronsted-Lowry acid is something that donates a proton, something that gives up its proton. So we can identify the acid pretty easily right here, HF, because we can see HF turns into F minus, so it lost its proton, right? The proton went to water, and then water turns into our hydronium ion. So HF, it donated its proton, it gave up its proton, so that's the acid. Now in this equation, water is the base, because the definition of a Bronsted-Lowry base is something that accepts a proton or gains a proton. And we can see this proton here, water gained a proton, and now it's turned into H3O, the hydronium ion. So we have our acid and our base. Now on the right side of the equation, we need the conjugate acid and the conjugate base. So what you need to know is the acid changes into the conjugate, I'll put C base, and the base changes into the conjugate acid. And the mistake that most people made on the test is they thought that the conjugate acid changed in, or they thought that the acid changed into the conjugate acid. And it does not. The acid changes into the conjugate base. Because, and you can kind of think about this, if we reverse the equation, if we went like this, right? Now, if we go from F minus to HF, then this is a base, right? F minus is a base because it accepts a proton, right? It goes from F to HF, so it gained a proton. So F minus is not an acid, it's a base, and we put the conjugate in front of there just because the acid, it was an acid and it changed into a base, and so we put the word conjugate in front of there. Same thing with H2O and H3O. Right now, H3O, if we flipped it, is an acid now, right? Because it's donating a proton, it's getting rid of a proton to turn into H2O, and so it's the conjugate acid in this equation. Okay? So the question asks, what of the following is formed when an acid dissociates in water? You can think of this. Acids turn into conjugate bases. Acid will always turn into a conjugate base, and a base will always turn into a conjugate acid. Okay, next one. Which of the following H plus values describes the most basic alkaline solution? So which of the following is the most basic alkaline solution? And then you get answer choices like 10 to the negative 2, 10 to the negative 7, 10 to the negative 13, and then some other one, right? We'll do like 10 to the negative 1. And it's asking you which is the most basic, and also alkaline means the same thing as basic, solution. So you could do this. These are just the concentrations, right, of H+. So you could use your equation, pH equals negative log of H+, and you could just plug all those numbers in here and see which one gave you the most basic solution. And hopefully we're remembering the pH, and actually that's the next question. So remember, neutral is 7. More than 7 is basic. Less than 7 is acidic. And so you could just plug all those numbers into this equation and see which one gave you the highest pH, and then that would be the most basic. Or you can recognize that these superscripts up here, the negative 1, negative 2, negative 7, negative 13, that if you go negative log of 10 to the negative 13th in your calculator, that it turns out that the pH of something with a proton concentration of 10 to the negative 13 equals 13. Something with a concentration of 10 to the negative 7, the pH equals 7 to 1. So you could just know that and say, okay, well then 13, this one, 10 to the negative 13, is the most basic solution because its pH is the highest. Okay, so you could just know that that's how this works, that the superscript is actually going to be the pH, or if you didn't know that, you could just plug them all into this equation and then see which one gives you the highest value. Which leads nicely into our next question here. Oops. The solution of vinegar and water has a pH of 6.2. What type of solution is this? So is it acidic, basic, or neutral? And more than half the class got this wrong, which was kind of disappointing. This is a fairly simple question. So the pH scale, remember, is right up here. So we have acidic equals less than 7. Neutral equals 7. And basic equals greater than 7. And so this is a pH of 6.2, which is less than 7, and so the solution is acidic. Alright, so the Bronsted and Lowry defined a base as which of the following? And you had to know this, the different definitions for a few questions on the exam. There was another question about what a Lewis base is, or a Lewis acid is also, and I'm going to go over those definitions right now. I'm going to pull up the PowerPoint. And so if we're looking at Bronsted-Lowry definitions, so the Bronsted-Lowry definition, and remember we're looking at the question asked, defines bases as which of the following? A Bronsted-Lowry base is a substance which accepts protons. It accepts protons. On the flip side, a Bronsted-Lowry acid donates the protons. And so that's why if we look up at that first question we did, that's why H2O is the base, because it accepted the proton. Right? It accepts proton. Bronsted-Lowry acids accept protons. Acids give them away. And so Bronsted-Lowry defined a base as which of the following? Well, it would be the one that accepts a proton. And remember, so when I'm saying accepting a proton, I mean accepting an H+ ion. Remember, people will say both of those interchangeably. Those mean the same thing. And so there was another question on, I can't remember, I don't know if it was asking about the Lewis acid or Lewis base. People did a little bit better on this one. But remember, Lewis acids and bases, oops, where's my definition of Lewis acids? Lewis acid accepts a pair of electrons, and Lewis bases donate a pair of electrons. And so you don't really need to know how to apply that for this unit. You just need to know the definition. So if you're going to retake the test, maybe write these down and then study them before you retake it. Lewis acids accept pairs of electrons. Lewis bases donate them. Alright, so make sure you have the Arrhenius, Bronsted-Lowry, and the Lewis acids and bases clear in your mind. And if we want to go, we'll see the Arrhenius definition. That one people did pretty well on, but let's go back in case you're writing these down and you want to remember them. The Arrhenius definitions: Arrhenius acid, a substance when dissolved in water, produces H+, so it has to have H in its formula. And then the Arrhenius bases, when dissolved in water, produce OH-, and so it must have OH in its formula. Alright guys, I hope this helped. If you'd like to retake the test, then write down the password and good luck.